Hi, everybody. Happy late night math with Miss Levan. This is your 3.3 formative review video if you're in my pre-algebra class, so periods 1, 2, 4, and 5. You're not allowed to laugh at the way that I look because it is late and I just got home from the gym and I was like, oh my gosh, I have to record this. I'm also wearing my Drake sweatshirt in honor of his new album release, obviously. Scott had to go upstairs because he was so embarrassed for me. So here we go. This is going to take you through all of the essential skills for your formative that will be on Thursday. And trust me, it'll be worth it that you're watching this video. So here we go. All right, so skill number 1 is for you to be able to look at a function and tell me if it's linear or non-linear. So remember, for something to be linear, that means that it has a crack. It has a constant rate of change. If it doesn't, then guess what? It's not linear. So for our first one, again, a linear function has to have a crack or a constant rate of change. So if I'm comparing function A and B, let's do it on a case-by-case basis. When we're looking at tables, we want to see if our x's are increasing at a consistent rate and our y's. So I can tell that my y's are all going up by 5. So it's plus 5, 5, 5, 5. My x values here from 3 to 6, I'm like, well, that's 3. This is also 3, 3, and 3. So because my x's are consistent and my y's are consistent, that means that function A is linear. So that one's good to go. This little graph here, this has like a curved line. So that is non-linear because it's literally not a straight line. There's no other easy way to say it. Okay, now when we're looking at equations, so you've got function A, which is this equation, function B, which is this equation. The moment that you see an exponent in your equation, that's going to be non-linear because it's going to graph something like that on your coordinate plane, and that's not going to be linear. Function B, I don't see any exponents, which means that this would graph a straight line, so that would be linear. So again, if you see an exponent, non-linear. Okay, so back to the tables. It seems like tables are usually the most challenging for us, so let's pay attention. So if I'm looking at my x category, I know that from -1 to 0, that's going up by 1. 0 to 1 is going up by 1. 1 to 2 is going up by 1. From 12 to 8, that's going down by 4. 8 to 4 down by 4. 4 to 0 down by 4. It's okay that it's going down. Who cares? But because this column is consistent and this column is consistent, that means that function A is linear. Yay! Function B, this equation, I don't see any exponents there. So guess what? B is also linear. Ooh, go crazy. Pretty cool, huh? Okay, it's really not that cool, but I think it is. Okay, skill number 2 is identifying your constant rate of change for a function and your initial value. Remember that this is the same as slope and this is the same as your y-intercept. They are synonymous, which means they mean the same thing. So for function A, first of all, I see that this has an exponent, which means that it's non-linear. Does a non-linear function have a crack? No. So we write no crack. Also, please ignore my spelling there. It does have an initial value though. This last little number here, this -7, that is going to be your initial value. So if you were to like graph this, it would be at -7 on the y-axis. So that's your initial value. For function B, guess what? This is linear, which means that it has both a crack and it has an IV. The crack is always the number stuck to X. Think about you when you have like a crack, if you put it in sport mode or whatever you put it on, you wear it on your shoe. It's attached to your shoe. So your crack is attached to X. If you need me to draw a little crack, okay, well, I tried. So crack is stuck to X. Your initial value is always your last number here. So because this is a +3, it's a +3. And there we go. Okay, so now I know we've already seen this table, but that's okay. For the crack of a table, this is what we probably struggle with the most. It's y over x, y over x, y over x, y over x. You just got to memorize it, say it in your head. That means that we need to look at what those y's are going up or down by first. So I already told you to get from 12 to 8, it's -4. and it's minus 4 all the way down. So on top of our fraction, it's going to be a negative 4. For our denominator, we need to see, okay, well, what's going on with the x's? These are all going up by 1, which means that we'll have a 1 at the bottom here. Well, I know that negative 4 over 1 is the same as negative 4. So that means that the crack for the table is negative 4. For the IV, remember, here's your trick. You look at where x is 0 and you pick the number next to it. So it's this guy. It's 8 right here. So your IV for the table is going to be 8. For this equation, to find the crack, it's whatever number is stuck to x. Remember, you wear Crocs on your shoes. It's stuck to x. So that would be 3. And then your IV is a positive 2. Yay! Okay, last one. Well, no, not really. For this table, please don't be freaked out that it's going horizontally. It really doesn't matter. This is still x and this is still y. The crack for a table is y over x, y over x, y over x, y over x. For my y values, I can see that these are going up by 5s. 5, 5, 5, 5. So I've got 5 on top. My x values are going up by 1 all the way across. Okay, well, guess what? 5 over 1 is the same as 5. So the crack for the table is 5. The initial value, we look at where x is 0 and we pick the number like next to it. Oh, what the? It's 8 again. Cool. I did not do that on purpose, but that is pretty cool. Oh gosh, Scott just texted me saying, why are you so excited about math at 9 p.m.? Well, that's my job. That's me, because I love you guys and I love math. That's why. Okay, so skill number 3. This is probably like the most, not like intensive, but it probably requires the most thinking for your assessment. There will be a written response on your assessment, which we'll practice in class tomorrow when you see me, where you have to compare like cracks, IVs, and all that jazz. Okay, so this is going to help you for that. Okay, so the first thing, you are comparing function A, B, and C. And the first thing we want to see is which one has the greatest or the biggest constant rate of change. Before you can even evaluate that, you need to find the crack for every single one. Let's start with the table. Okay, the crack for a table is y over x, y over x, y over x. I know you're getting so annoyed by me doing it, but I want you to remember y over x. So my y's are going up by 5 over x's, which are going up by 2's. Okay, well, 5 over 2, that is the same as 2.5 or 2.5. So your constant rate of change for the table is 2.5 or 2.5. Okay, done. Function B, well, guess what? The crack is the number that's stuck to x, so that's just 3. For your graph, we need to find some nice little points on our coordinate plane. And then you've got to ask yourself, because it's the same thing as slope. To get from this point to this point, I go up by 1 and over 3. Up 1 over 3. Okay, so you did your hard work. My recommendation on your assessment, even though it's on your Chromebook, I would use scratch paper and like literally like write this out. So like function A, this is your crack. Function B, this is your crack. C, this is your crack. Now, when I'm looking at the numbers, which one is biggest? 2.5, 3, or 1/3? It's this one. It's 3. That's your biggest number. So you say function B has the biggest crack because it's 3 compared to 2.5 or 1/3. Okay, now we're going to use the same diagram, but what we're going to compare is the initial value for each one. Okay, so for function A, we look at where x is 0 and we pick the number next to it. Guess what? It's 0. So the initial value is 0. Cute. For function B, the initial value is right here. Notice the sign, that's going to be -1. For my graph, it's wherever it crosses your y-axis. It's the y-intercept. So that's going to be right here at 2. So if I'm comparing 0 with a smiley face, -1, and 2, 2 has the biggest IV. I mean, oh my gosh. C has the biggest IV because it's 2 compared to -1 and 0. As a side note, for rewards for listening to this, If you and your written response tomorrow, Thursday, tell me your favorite food, then you will get an extra point. So in your written response, if you like type out your whole thing and you're like, by the way, Miss LeMann, my favorite food is peanut butter or pizza or Panda Express or crumble cookies, I don't care. You will be rewarded. Okay, so now let me just go through. Oh, there's one more. Sorry. Okay, last thing. If it's just a graph and we want to find the crack in IV, first of all, your IV is wherever it crosses your y-axis here. So that's going to be 1. Your constant rate of change is the same as slope. So essentially how you're moving. So I can see that this is going up 1 over 1, up 1 over 1. 1 over 1 is 1. Okay, let me do a really quick video recap. On your 3.3 formative, you have 3 skills to do. Your first skill is to identify if something's linear or nonlinear. When you're looking at a table, if your x's are going up or down consistently and your y's are consistent, it's linear. If you have a graph, if it's a straight line, it's linear. If it's not a straight line, it's not linear. That's it. When we're looking at equations, if it has an exponent, non-linear, because it's going to craft something whack like that. If there's no exponent, you're going to go. It's linear. Also, I don't know how many times I can say this, but if you have an equation like this, y equals 5x plus 3, 5 is your croc. 3 is your IV. You wear Crocs on your feet. It's stuck to X right here, right there. You will also have to be able to identify the croc and IV for different functions. So again, if you're looking at an equation, the number stuck to X is your croc. The last number is your IV. If you have a function that's not linear, well, guess what? There is no constant rate of change, but there is an IV. It's this last number. Okay, for a table, I'm going to erase so I can like re-show you. Okay. Uh-oh. When you're looking at a table to find the IV, you put your pencil or your cursor where X is 0, and you pick the number next to it. So this is your IV, it's 8. Okay, and then last thing, to compare constant rate of change and initial values. Before you can do anything like this on your assessment, again, I would write it out on a piece of paper. So like find the crack for A, find the crack for B, for C, and then you can pick which one's bigger. Find the IV for A, for B, for C, and then you can find which one is bigger. If you paid attention this whole time and you got my secret code from the video, good for you. I'm proud of you for studying, but you're going to do great. You've done a lovely job in class this week. I've been very proud of you. We have one more review day tomorrow, and I think that's it. Okay. Peace, love, Drake. I love you. See you in class tomorrow. Bye-bye.